Hi everyone, this is Mrs. Jackson, and the topic of this video is how to use the box method to factor quadratic polynomials and further use that technique in how to solve quadratic equations. Before we do that, let's look at how to multiply binomials together using the box method, and I think that will be very illustrative in how to apply the technique in reverse to factor. So take a look at this diagram. This is something called algebraic tiles, and it's really meant to show variables and constants in the form of geometric area, more of a tangible way to look at algebraic expressions. So here I have two x's, if you look up on the top, two x's, and I have three ones, and we're going to represent that here as two x's and three ones. And over here I have three x's and just one. So this is meant to try to illustrate what it would look like to multiply two binomials together. 2x plus 3 times 3x plus 1. And we're really looking at this sort of like geometric area. So if we just home in here on the yellow space, we've got an x times x, and of course that would be an x squared. And if you notice, each one of these will result, x here multiplied by this x would be another x squared. So we actually have 1, 2, 3, 4, 5, 6 x squared. So I'm going to go ahead and erase those, and hopefully you can see that 2x then times 3x is going to give us 6x squared. And that's really, think of that as literally the geometric area of this yellow space here. And now looking over here, 1 times x would give us 1x. 1 times x would give us another 1x and another 1x. And if we count these all up, we would end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, which would give us 9 x's, and that's represented by the pink. So hopefully you can see that this pink rectangle here, right here, would be 3 times 3x would then be represented by a total of 9x. Likewise, over here, we've got 2x times 1, and I think you guys get the idea that this would be 2x. I put both of these geometric areas here in pink because hopefully you see that they are like terms and they will be able to be combined. And then finally we've got 1 here multiplied by 1 here, and we just get 1 and another 1 and another 1. So 3 times 1 would give us a total area of 3 here. So I'm just going to represent that by 3. So we can add all of these terms up, and we have 6x squared, and we have 9x, and we have 2x, and I'm summing these because I'm trying to get the area, if you will, of the entire outside rectangle. So essentially we are trying to find the area of a rectangle whose base is 2x plus 3 and whose height is 3x plus 1. And that will give us that total area of that rectangle. And if I sum these two together and I get like terms here, then I get 6x squared plus 11x plus 3. Notice that 11x is arrived at by combining these two terms here, 9x plus 2x, and that's very important to notice that relationship, because that's how we're actually going to be using this method in reverse to factor. Okay, let's practice a little bit more multiplication, and this time I'm not going to use the algebraic tiles. I'm just going to draw here a simple 2 by 2 box. And so you can put your 5x minus 1, either you could put that up here or here, it doesn't matter. I'm going to put it over here, but it doesn't matter. Just be careful with the sign. 5x minus 1 is the same thing as 5x plus a negative 1. So make sure you grab those signs. And start doing your multiplication. 5x times 2x is 10x squared. Negative 1 times 3 is negative 3. And then we're going to end up with the like terms. 5x times 5x here times 3 is going to give you 15x. And 2x times a negative 1 is going to give you negative 2x. And when you use these box method, you're going to see that the like terms are going to fall on the diagonal. So we have 10x squared, and we've got minus 2x plus 15x minus 3, and we can combine those like terms. Whoops, I forgot my x here. And we have 10x squared. Negative 2x plus 15x is a 13x, and minus 3. And specifically the direction said put your answer in standard form. Standard form means that you are writing the terms in descending order. That means start high and go down, descending order of exponents. So we have an exponent of 2, exponent of 1, and right here we just have our pure constant. Okay, so let's go ahead and try one more. X minus 7, 4x minus 4. And we end up with 4x squared. And negative 7 times a negative 4 is positive 28. And now let's look at our like terms. Negative 4 times x is negative 4x. And negative 7 times 4x is negative 28x. And again, those like terms fell on the diagonal, and we could combine 4x squared minus 28x minus 4x plus 28, and our like terms are right here. We get 4x squared minus 32x plus 28, and this is in our standard descending exponent form. And this is how we would use the box method to multiply two binomials together. In a generic or general sense, the standard form you've probably seen last year in algebra is ax squared plus bx plus c. And this a here, all it is just whatever this coefficient is, a number. Same thing with b, and same thing with c. And this is what we would call a quadratic. Whenever we have a x squared term, you don't even need the bx or the c term at all. As long as it has that x squared term, then we would call that a quadratic. Okay, now how do we use this technique, this box technique, in reverse? And by that, I mean this time we're starting with a quadratic, and we want to figure out what these two binomials are, what the factors are. How can we split that quadratic back up into these factors? And the whole purpose of doing that, we'll see on the next page, is to actually use it to solve quadratic equations. So how can we do this in reverse? Well, let's look at a pattern up in one of these two examples. First of all, whatever this first term is here, this 10x squared, well, that was in that first box. And whatever this c is, this pure constant, well, that was in this box. So let's go ahead and start there. 5x squared here and negative 3. Just put it in the box. We know they're going to be in there. Okay, and so our task at hand is to find out what these two terms are on the diagonal that when summed together are going to give us this negative 14x. So how can we do that? Well, we're going to try to look at factors here. So what we're going to do is we're going to multiply 5 and negative 3 together, and that is negative 15. And we want to look at factors of negative 15. That means multiplication, factors, that sum to whatever our b is, this coefficient here in the middle, the x term. So we want to sum those to, in our case, negative 14. Okay, so what are some of those factors of negative 15? Well, let's take a look at some numbers. There are many factors of negative 15, so it's kind of, this is a little bit trial and error. We could easily start out, I guess, with negative 15 and a positive 1, or a positive 15 and a negative 1. Hopefully you see that these sum to negative 14 and plus 14. But there's also 5 and negative 3 if you wanted to, or negative 5 plus 3. And you can see that they don't sum to the number that we're looking for here. We've got, oops, this is supposed to be a plus 3. So we found ours right up at the top of the list. This is what we're looking for. So what we're going to do is use this negative 15 and positive 1 to represent these terms on the diagonal. It doesn't matter where you put them. You can put negative 15x here and 1x, positive 1x here, or reverse that order. It really doesn't matter. I'm going to go ahead and put negative 15x here and positive 1x here. And so hopefully you see that again on our diagonal, this is going to sum to that negative 14. Okay, I'm going to go ahead and now, what are we trying to do? We want to go in reverse. So how we're going to look at this is we're going to take each row separately, top row, then the bottom row, and then we're going to look at each column separately. First the left column and then the right column. Now what I want to do is I want to look at 5x. So starting here, I want to look at, actually maybe I should just cover this here. I'm just going to try to cover this here. We're just going to look at the top row. Hopefully I can erase that in a moment. So what can be divided out of both of these terms? In other words, what's the greatest common divisor? Well, both 5x squared and negative 15x can be divided by 5. And hopefully you see that they can also be divided out by x. Okay, now let's look at the bottom row. So I'm going to go ahead and get rid of that, and I'm going to cover up the top row here and just take a look at the bottom row. Now what can both of these terms be divided by? Well, 1 and negative 3 are both prime. So really, they're only divisible here by 1. We can't divide both terms by x because there is no x in this negative 3. Okay, now let's look at the columns. So let's start out with the first column. So I'm going to go ahead and just try to hide this column. Now what can 5x squared and 1x be divided by? Well, they can both be divided by x. Alright, so I'm going to try to get rid of this. And now let's look at the last column. I'm going to cover up the first column here. And let's look at what can negative 15x and negative 3 be divided by. And what they can be divided by here is negative 3. Now how do I know whether I should put a negative 3 or a positive 3? Well, just going back and thinking about multiplying and getting what we need in the box here. Since we've already put 5x, positive 5x over here, and we want negative 15x in this box, then this would have to be a negative 3. All right, so there we have it. We've actually factored this. We've got 5x plus 1 on one side times x minus 3 on the other side. And if we wanted to check our work, we can go back and multiply this all together and just make sure that we end up with this quadratic that we started from. Okay, now let's apply the same concept to really why we would ever factor to begin with, which is to try to solve a quadratic equation. Notice this time we have an equal sign, and so we're going to try to find values of x that satisfy this equation. And when we have a quadratic, or a degree of 2, an exponent of 2, we could have up to 2 solutions. We could have 1 solution, or we could have no solutions. So let's try to see how we could apply this technique. First of all, we always want one side of the equal sign to be 0. So I don't want that 6 there. So I'm going to use the subtraction property of equality. and I'm going to get 6 minus 6 to be 0 on this side. So I've got 2x squared minus x, negative 9 minus 6 would be a negative 15. Okay, very good. Now let's try to factor this side here using our box technique. So as always, we're going to put that 2x squared here in the box and the negative 15 here. We're going to multiply those together and we get negative 30. So we're looking for factors of negative 30 that sum to our negative 1 here. Hopefully you see that the coefficient in front of this is a negative 1. So we want them to sum. And there are many factors of negative 30. So we could look at things like negative 15 and positive 2, or positive 15 and negative 2. Hopefully you see right away that this isn't going to yield what we're looking for, because we're looking for two numbers that are so literally one digit apart in order to get negative 1. So you can go through 3 and 10, etc., but hopefully with not too much work, you're going to notice that really 5 and 6 are what we're looking for. So if we make the 5 a negative, or the 6 negative, then we would end up with a sum here of positive 1 and this one of negative 1, and in fact that's what we're looking for. So we're going to rewrite this negative x as 5x, and we've got over here, so we've got 5x minus 6x, and that's going to give us this negative 1x when we sum them together. Okay, now let's just focus on the top row here. What can be divided out of the 2x squared and the 5x? Well, 2 and 5 don't share any factors, so really just x can be divided out. Now let's look at the bottom row. What can be divided out of negative 6x and negative 15? Well, I'm thinking negative 3 can be divided out. Now let's look at the left column. What can be divided out of 2x squared and negative 6x? Well, we definitely have an x in both terms, and we can divide a 2 out of both terms. And finally, the last column, 5x and negative 15, what can be divided out? We can divide out a 5. All right, so we've got x minus 3 is one factor, and 2x plus 5 is another factor. But don't forget, we have this whole quadratic here is being rewritten as the product of these two factors, but don't forget it is an equation, so we have that equal to 0. And this is the power of factoring. Now we can actually solve for x by putting both factors equal to 0. So we have x minus 3 equal to 0, and we have 2x plus 5 equal to 0. And we're going to solve this by adding 3 to both sides, and you can see very easily x equals positive 3 here. And over here, we are going to subtract 5 from both sides, and we have 2x equals negative 5. And we're going to divide both sides by 2, and we end up with x equals negative 5 halves, or you could call that negative 2.5 if you want to. And in this case, this quadratic equation resulted in 2 solutions for x. All right, let's try it again. So over here, we have 4x squared plus 14x plus 10 equals negative 2. As was the case before, we want to make sure that we have 0 on one side, so I'm going to add 2 over here. And we end up with 4x squared plus 14x plus 12 equals 0. Now, notice that every term here, 4x squared, 14x, and 12, are all divisible by 2. So I would recommend that you factor out 2 right away. It just makes your math a little bit easier. So we're going to take 2 out of everything. So 2x squared plus 7x plus 6 equals 0. And this 2 really, if we divide everything by 2 now, then the 2 just goes away. So it just makes everything easy. We're going to divide this side of the equal sign by 2, this side by 2. 2's gone, and over here we still end up with 0. So now we're trying to factor 2x squared plus 7x plus 6. And just like we did before, we're going to put the 2x squared in the box and the 6 in the box. All right, multiply the 2 together, and we end up with 12. So we're looking for factors of 12. And that sum to our b here, which is plus 7. All right, and there's not that many factors of 12. We got 12 and 1, 6 and 2, and hopefully you see it's pretty easy. It's 4 and 3, sum to 7. So we are going to rewrite this 7x as 4x plus 3x. And we got that from our 4 and 3 here. All right, let's start with the top row. What can be factored out of both? 2x squared and 4x, well, we can factor out a 2 and an x. Looking at the bottom row, what can be factored out of 3x and 6? We can factor out a 3. Looking at the left column, what can be factored out of 2x squared and 3x? We can factor out just an x. And looking at the final column here, the right column, what can be factored out of 4x and 6? We can factor out a 2. So we have 2x plus 3 times x plus 2 equal to 0. So those are our factors, and we're just going to take each of them separately and put them equal to 0. So we've got 2x plus 3 equals 0. And to solve that, I'm going to subtract 3. And I end up with 2x equals negative 3. And I'm going to divide both sides by 2. And I end up with x equals, that's a 2 by the way, negative 3 halves, or you could call that, you could put it in a decimal, negative 1 and 5/10. And x plus 2 equals 0, and just subtract 2 from both sides, and you get x equals negative 2. So these are our two solutions to this quadratic equation. Now, I mentioned on the previous page, but it might have been subtle, that factoring doesn't always work. Factoring may not work because there might not be a solution at all to this quadratic equation. We're going to talk about that in another video, but there may not be a solution at all. Or, more likely, the solutions are not simple fractions or integers. They may be, in fact, irrational numbers. They may be the square root of something that's not a perfect square. They may be an approximation of a decimal or a more complex fraction. So that can occur, and let's take a look at this simple equation here. X squared plus x minus 3 equals 0. We have our equal 0 to one side, so we're going to go ahead. We're going to put our x squared in the box and our negative 3. And we're going to multiply these two together. So we've got 1 times a negative 3, which is negative 3. So we're looking for factors of negative 3 that sum to this positive 1 here. So negative 3 or 3 is just a prime number, so all we have is negative 3, positive 1, or positive 3, negative 1. And if we sum those, we don't get what we're looking for. We do not get positive 1. We have only negative 2 or positive 2, and that's all we got. So right here, this should tell you automatically that this is not a quadratic equation that is factorable. And it may be that it's not factorable because there's no solution at all, or more likely it may not be factorable because the solution is possibly an irrational number, such as a square root of a non-perfect square. That would lead to a decimal that is non-ending, that goes on forever in a non-repeating pattern. And so we would have to approximate that number to a particular place value that we'd want to, either tenths or hundredths place. And so in the end, if we have a complicated set of solutions that way, we're not going to be able to solve this by simple factoring, because we can start looking at decimals here forever, and that type of trial and error process would just be too cumbersome. So that's not going to work. So in this case, this quadratic is not factorable, and we would not be able to solve it using this technique. We would have to go to something called the quadratic formula, which we're going to talk about in the next video. So hopefully this helped you use the box process to both multiply binomials and use it in reverse to factor quadratics and eventually solve quadratic equations. So hopefully this helped, and please subscribe to my channel. Thanks for listening.